It's a pleasure to host this webinar for you. This is our 104th webinar in the series of technical webinars that we are conducting every month. As a practice, we are conducting one webinar each month. And please follow us on LinkedIn, YouTube, and make sure to check our website also for the latest updates. Coming towards the speakers, today we have an experienced panel of speakers. I am with my colleague, Mr. Ijazul Karim Rao, who's Managing Director and Principal Integrity and Safety Consultant. Then Miss Madam Mubina Khatun, she is Director Engineering Services at Velosi. Mr. Anthony James William, who's General Manager for Global Sales, and myself. Now coming towards the agenda, since this is a quite technical subject, so we will touch only the key theoretical and practical aspects of implementation of asset integrity and process safety management system using VAIL-AIPS software. In this limited time of 2 hours, we request you all to follow along with us and keep asking questions to help us make this session as engaging as possible. So I will start with a Velosi introduction. So let us begin. Velosi is a leading consultancy firm that provides asset integrity, HSE and environmental engineering services and software development services along with training services. We have our footprints in more than 86 countries worldwide, and we have more than 43 years of experience. Velosi has completed more than 1,300 projects with 500 different clients worldwide. So basically, the group was founded in 1982 in Malaysia, and then it was acquired by APLIS Spain in 2011. So we operate globally through our associate offices in Middle East, Africa, and Asia. Our corporate offices in UK, and head office is in UAE, Abu Dhabi. So our area of expertise are asset integrity management, HSE, engineering, software development, and training. And now we will start with the topic. I will request Mr. Ijazul Karim Rao to start with today's topic, that is asset integrity and process safety management system.
Assalamu alaikum and good day everyone. We know that it's afternoon here in Abu Dhabi and late evening in Far East and early morning in Europe. So we have participants from all parts of the globe. It's interesting to see that. Today's topic is a more interesting one, and it is more like for the people who works in the management side and who are responsible for the asset integrity as well as HSE management processes. So this topic is like a new concept, or you may say is being resulted from two cultures. One is OSHA, PSM culture coming from US, and other one is HSE MS and AIMS concept coming from HSE Executive UK or HSE UK. These are two basically regulatory authorities who are having their own system, and those systems are being applied with merger or with individual streams by various organizations across the globe. We will have one break in between where we'll say question answers after case study 1, and then there would be one question answer session would be at the last. So please keep writing your questions in the question answer window so as we can take a break, and we will also give a chance to the participants to interact with us and ask those questions so as other audience can also listen those questions and our answers as well. So what is AIMS? Like since we are working at AIPS, so this would be a combination of AIMS plus PSM is AIPS, and then also PSM and HSEMS both cover more or less similar aspects. So we have to understand this concept. So AIMS is not artificial intelligence management system. This is asset integrity management system. So nowadays, a lot of debate is there about artificial intelligence. So here we are not talking about artificial intelligence. We are talking about asset integrity management system, right? And AI, of course, can assist in the later stage whenever required, right? Whenever applicable. But as such, we are talking about a domain knowledge. We are talking about a subject knowledge, not like a computer based asset like artificial intelligence. Yes, artificial intelligence plays important role in all these streams, very much relevant. We will see that also in the part of the presentation and discussion. But we are talking about here is asset integrity management. What is asset integrity management? So generally, it covers three phases of the life cycle of an asset: design integrity, technical integrity, and operational integrity. Design integrity means when the assets are being built, being designed. That stage we call design integrity. Procurement process is there. Sorry, design process is there, procurement process is there, fabrication and installation is there, and commissioning is there. So those four phases of the project life cycle are covered under design integrity. Then operational integrity become more relevant, like how you operate the plant, the use of operating manuals, the use of DCS, the use of ESD system, the use of fire and gas detection system, and the interaction of the operators with the plant interface. That is called like operating integrity. Like we have to operate the plant within integrity operating windows or operating limits, and so as there is no abnormality comes out of the plant. Then in between there's a technical integrity, means like generally it covers like inspection activities, preventive maintenance, condition monitoring, predictive maintenance, and how you manage the facilities or the modification processes. So in general, to have more efficient operations, more reliable operations, more safe operations, all three aspects are more important and relevant. Like then next thing, what is HSEMS? HSE, H mean health, S mean safety, E mean environment. So MS mean management system. Mean if we are having any running facility or operating plant, so there could be some side effect or there could be some operational threats of those operations which are being run. For example, if we are producing fertilizer, if we are producing glass, if we are producing oil and like this diesel fuel and gasoline fuel out of the crude oil, or if we are producing crude oil or gas from the wells, from the underground wells. So all these aspects may have certain HSE related threats, and we need to manage them. Because let's say if a toxic gas may release out of any process that can kill people. So we need to make sure the toxic gas does not come out of the boundary of the equipment, does not leak. If leak, it can be predicted, it could be detected, and then the operators or the surrounding of the facility should be able to take the proper protective actions. Similarly, any flammable fluid can create fire, so prevention of the fire is another area. Similarly, if operators are working on any particular plant, in that scenario, if there could be any health impact on the operators due to the release of any vapor or any chemicals being processed by the facility, so those should also be managed. Similarly, work permit system, work processing, like if any hot work permit, cold work permit, or the PPEs like helmet, safety shoes, coverall. So all these aspects are covered under HSEMS. And under HSEMS, like it is mainly governed by like ISO 45001. Also, like there are HSEMS from the HSE Executive UK. So there are various 8 elements are there. In ADNOC, there are 23 elements. So these elements help to prepare procedures and practices. And then you also have a daily monitoring and reporting system, and that is also called like HSEMS dashboard. So these all aspects are covered under HSEMS. The purpose or the objective of HSEMS is mainly to have a protection against any HSE related threat, and this process is basically covered by HSE Executive UK or ISO 45001 or OSHA from US. PSM, basically, you may say like sometimes like there is some sort of rivalry or some sort of comparison. Like if you go in US, there is a right-hand drive, and if you go in Europe, there is a left-hand drive. So even both cars could be the same right hand. So all cars could be used in the whole world, but both these respectable continents are having two different approaches or opposite approaches. Similarly, HSEMS in UK or PSM of OSHA in the US could have a common objective, but still that kind of streamlining is not there. And now the some standards are coming out of Russian Federation as well as from the Chinese regulators. So those would also be coming in the picture in next uh, few years, what we can see. So here PSM means Process Safety Management System, and main element or common element in HSEMS and PSM are more or less same, but there is a one additional basically element which is part of PSM OSHA, but not in HSEMS of UK. So that is the mechanical integrity, but like it could be better if it could be named as technical integrity and operational integrity. However, the PSM elements, which are 14 elements, and the HSEMS element, which as per UK there are 9 elements. Elements mean like what minimum factors or aspects for any working process should be considered. Those are called basically elements. So the purpose of PSM and purpose of HSEMS is more or less same. Additionally, in PSM, there is a focus on asset integrity or mechanical integrity as well. So there's one more standard which is normally called basically CCPS, and this is the Center of Chemical Process Safety. And this CCPS have 20 elements. If we try to make a comparison, all these elements are basically correlated, and we can make their comparison. Similarly, there are API standards like API 750, API 14J, API 754, and other API standards are also there, like API 584 and so on. And NFPA 30 is also another area which gives good advice regarding the process safety related issues. Now, if we see like what the purpose of all three, like if we say AIMS, HSEMS, and PSM. So we are not saying so far AIPS, which is asset integrity and process safety, but like the focus of AIMS, clearly it is asset integrity management related objective, HSE mainly managing the safety, and process safety by name, it covers practically both because the process safety cannot be achieved if we will not have a better AIMS system. Because the process safety, if, for example, if alarms are not being attended by the operators, then there could be an accident. If a proper inspection and maintenance program is not being developed by the operating company, there could be incident. So the combination of HSE related controls like a PPE's control, work permit system control, and other risk identification and risk management related controls, along with asset integrity management controls, those are taken care by PSM. And there is a commonality between AIMS, HSEMS, and PSM, which is basically the safety, health, and environment related aspect. Then there is a indirectly or directly there is a commonality in all three concepts. So there is scope name wise, like aims main focusing on the assets, equipments, inspection, maintenance, lifecycle management, and its integrity. Similarly, HSEMS more towards workers, environmental and the safety aspects, health aspects, or environmental aspects. Then when we have PSM is basically, in my view, a combination of both AIMS and HSEMS. So the standards wise, ISO 55001 is the basis for the AIM system. Then HSE Executive UK or ISO 45001 or ISO 14001. These are the three standards which make the basis for HSEMS. Similarly, OSHA PSM 29 CFR 1910-119 provide the basis for the PSM. Similarly, CCPS also plays this role. The elements point of view, we say, as I said earlier, you will see next slide. AIMS got 7 elements, then sub-elements are there. HSEMS got 9 elements, PSM got 14 elements, and CCPS got basically 20 elements. Then there's a possibility we can integrate all three systems together, and the main objective of all of these processes is avoiding the incident at the facilities. Now, challenge. Like, what are the challenges what are being faced if we have to implement these three systems or combination of these three systems? See, if we see the facilities, the from design to construction to operation, it is a very complicated process, and various disciplines like process, mechanical, electrical, instrumentation and control, HSE, structural, civil, all these aspects are being built, and then there is a cross functioning of the systems and so on. So there are like complicated operations, variables changing, and environmental condition changing. So to have all this, we need to be more and more committed. We need to have a more and more documented system. So that is one of the challenge. Second part is the like a people, culture, and a skill, like leadership commitment. Number one. Number two, people's empowerment. Number three, availability of the manpower to do the job. Number four, like if next thing, like if whatever issues are there, if those are being reported on the actual facts. For example, if a trip is there, it should be reported as a trip on the genuine cause. If there's a leak is there, and why leak was caused, what kind of root cause was there, if it's identified properly. For example, if PMs are use of like a CMS system, SAP, Maximo, or Oracle or other system, if that is being used as a true recording of the events, or it is being done just to show the compliance. So then engagement of cross-functional people like operation, inspection, maintenance, safety, if those aspects are being working in a proper integration culture-wise. So like a truth reporting, as I said earlier, also is one of the threat. Then risk and hazard management. For example, if all risks are properly identified, all hazards are properly assessed. For example, if you see on the plants, the companies or operating companies that are taking care of the main reactors, equipments or rotary equipment. But what about the piping systems? What about utilities? Like in general, every equipment or component is important. Let's take an example of an instrument air. Though it may not carry any direct hazard, but if an instrument air fails, the whole plant will go and shut down. When shutdown happens, then there are a lot of safety and other related issues may come up. So similarly, sometimes the process water may not be seen as a hazard creating, but indirectly it can create hazard. So to knowing the system, knowing the subsequent impacts, and having proper risk profiling is another challenge. Then if data, for example, if events log is being done properly, if there are certain failures or some certain leakages or certain issues, if those are recorded and the trend is being seen, like if we want to use AI model to make some to help us to certain decision making process, so that AI model can work if we will have some real time data of the facilities, and that data may tell us which kind of equipment are facing which kind of problem. Then accordingly corrective action can be arranged and preventive action can take place as well. So the important, and then if the data would be properly recorded, then it will give us the history and the legacy, like what happened in past. Then next thread is governance and compliance, like how the leadership is governing the facilities. Like if any report which is being submitted to the regulators, how that report is being prepared, if that is based on the facts or that is for the sake of compliance. And then if the compliance is shown on proper way, then it can prevent many unwanted trips and events. Then to check the application of the working culture, if audits and assessments are being done, if assessment and audits would be done, then we would be able to see like internal departmental checks, internal departmental audits, like what we were supposed to do, are we doing that? Then but the main last aspect, which is the main, like demanding, everybody wish to do many things, but then we see the shortage of manpower, and there is a equilibrium between the like how much we can spend and how much we can do. So those aspects, budgetary constraints, the creating a balance between like the management system as well as the cost is another challenge. So these all aspects give us problem while implementing AIMS, HSEMS, and PSM system effectively. So here elements, why just like these are the 7 elements, there are sub elements as well, like ISO 55001, context of the organization, leadership, planning, support, operation, performance evaluation, and improvement. So there are 7 elements, there are sub elements as well. But one aspect where I would like to draw your attention, that is the development of strategic asset management planning. I have heard many times this discussion from our clients. Like they say, oh, we need to develop strategic asset management plan, and this is the problem for ISO 55001 because we don't have that. In my view, it is known to every facility. This is not a threat, not a challenge while implementing 55001 like a certification. What is strategic asset management planning, if we would like to say? So we have to see how the plants are being operated generally nowadays. General, I'm saying not everyone, general. So they say, first of all, we try to identify insurance related equipment or more critical operational equipment. For example, compressor and turbines, which are driving the delivery of the gas. Or there could be key pumps and compressors or reactors, which are a mandatory part for the any operation. So we know that those equipments are more critical. So like for gas turbines as well as the compressors, mostly companies are following OEM-driven asset management policy. It means they are taken care. Then for pumps, there are always or mostly 2 pumps, one operational, one standby. Then on that we got ESD system, and then we also got BPCS, basic process control systems. So we know that like pumps wise, if there would be an issue, we will be having a time to move to second pump and it will not disturb the operation. Similarly, all the BPCSs are taken care based on the feedback or operational log results of the operating control rooms, because operator will tell this alarm is coming more and more like a spurious, or this trip is occurring more and more spurious. So we need to have some proper correction or preventive maintenance for that particular asset. So in this way, so we already know this is our strategy for the operating the plant. Now, if we convert the same asset management strategy to asset management plan through CMMS, but important thing is we should know asset register. We should know whether what kind of strategy for the operation and maintenance we wish to follow, from operating manual to training of the staff to then rationalization of the alarms, and then identifying the critical alarms and medium critical alarms and low critical alarms, and then going back to the inspection and preventive or condition rating maintenance plans. And if we are having those plans implemented through CMS system, so we don't have any problem implementing ISO 55001 certification requirement. And ISO certification 1, okay, like one thing is, if you see that understanding the organizational and aspects in its context, understanding needs and expectation of stakeholders, determining the scope of the asset management system. Asset management system like a decision-making process, leadership, planning, support, operational performance evaluation, improvement are the same as you see under ISO 55000, sorry, ISO 9001. So it means like only the context of the organization and managing the assets as we should be managing. So it meets the requirement of 55001 easily. So the elements of the HSE Executive UK, which are 9, if you see that, like the first thing is the policy, then planning, risk profiling, then organization, then implementing your plan, measuring performance, and so on. So these are the 9 elements which are coming from HSE MS of UK. These are the 14 elements of PSM from OSHA Standard 29 CFR 1910-119. Here, the only one aspect which draws attention, that is mechanical integrity. Practically, it should be like the technical integrity, so as electrical and instrumentation and rotary equipment, especially electrical and instrumentation, civil and structure should also be brought into the same umbrella. But OSHA chose mechanical integrity, so but we consider it technical integrity all aspects. The pre-startup aspects, then emergency planning and response, compliance audits, so training, operating procedures, up to a certain extent can cover it, but if it could be under operational integrity, it could be easy. So these are the like a 14 element, like covering one by one as employee participation, process safety information, process hazard analysis, operating procedures, training, contractors, management, basically pre-startup review, mechanical integrity, hot work permit, management of change, incident investigation, emergency planning and response, compliance audit, and trade secret. These are the 14 elements for the OSHA. Standards, what we are referring, there are 55,001, OSHA 1910-119, and HSEMS, which is HSE G65. And if we try to find like the equivalent standard in ADNOC, so ADNOC also got basically asset integrity management standard, or no other, you say, control procedure. They also have HSEMS, and they have also developed AIPS standard as well. So here, this is the front page of ISO 55001, year 2024, is asset management system requirement, and these are the elements, like if you wish to see them, 7 elements, like starting context of the organization, same, leadership, planning, support, operation, performance, evaluation. Similarly, this is the outline I have taken from OSHA 1910-119 from their web page. So these are 14 elements. A lot of text is there, but there's explaining each element. But these elements, if you wish to see them, is a safety management system or a process safety information. Process safety information is here. So similarly, like these are the 14 elements. I'm not going through, just to show you. Okay, their details available in this document which is attached, and this document can be downloaded. Both OSHA as well as HSEMS can be downloaded from their web pages free of cost. Whereas this HSE G65 also available, and this reflect the 9 element under the aspect of like part 1, part 2, like a plan, then part 2 do, then act, plan, do, and then resources, and so and so. So these elements are basically coming from the HSE G65. If I can see that, like, yes, plan here, do, check, act. Under these 4 areas, so this is system, say, plan, do, check, act, and that was the basically the concept in that picture, which I see here. Plan, do, act, and check our performance, and then accordingly their sub-elements are governed by the HSE 65 standard. So these are the standards. Now, if we try to compare them, like mostly things are matching, like let's say risk profiling, or the aspects of, for example, planning, if you see here, or support, or operations. So we try to bring in the elements are superseding, or they are saying some alignment is there either in the main element or in the sub element. So it's a little bit complicated, but what we are trying to show, just like in ISO 9001, ISO 14001, and ISO 45001, we call it IMS. That IMS, it shows that like we can have an integrated management system. IMS not inspection management system, there is an integrated management system. So all 3 standards are having basically 7 elements, same as ISO 55001 is also having 7 elements. So if we align them, then our document or a processes can comply with all 3 requirements in parallel. That is the purpose. If we understand the sub-element and element correlation, then under one procedure, we can comply with all 3 or 4 applicable standards. This is the purpose. Now, what is AIPS? Basically, AIPS, somebody can say AIMS plus PSM is AIPS, asset integrity and process safety. When we say process safety, is a process safety, HSEMS is also part of, direct or indirect part of process safety, but is more towards the people, whereas process safety is more towards the process. So by combination of this, by focusing AIMS and PSM together, so we may cover both HSE as well as asset integrity management through one umbrella. Even though, like in ADNOC, still they are having 2 like VPs in the organization. One VP is for HSEMS, another VP is for AIMS. Or there are also some scenarios where we got AIMS, also the one VP or manager for the PSM. So can we have one manager for both? That is the target. Like if we combine AIMS and PSM together and we make AIPS, then organization structure wise, there could be one organization rather than two organizations as we are having nowadays, AIMS and HCMS or AIMS and PSM. So that is the like consideration or soul searching ongoing in the various organizations. And ADNOC has come forward to make AIPS, and this standard has been issued, I think, 2-3 years ago, and now under implementation phase. So now, like one thing to understand, there is a certain risks which are coming from AIPS, asset integrity process safety, asset integrity and process safety, not artificial intelligence and process safety. Then HSEMS. HSEMS is, you can see, a small triangle, whereas AIPS is a big triangle. Why so? Is a danger this way. This is a reflection. Somebody may have a different view, but it's an overview. HSEMS means people may get affected by pitfalls, by falling from the height or not following the work permit system, or there could be people management related assets issues. But here, process safety, there could be a big fire in the plant due to leakage, due to equipment failure, due to ESD system failure. So AIPS risk is a lot bigger than HSEMS risk. Both risks not acceptable. But if we see the magnitude point of view, the magnitude is saying the HSEMS risk is far smaller as compared to asset integrity and process safety related risk. So now, if we have to have a system, right, of AIPS and HSEMS, how that system may look like. So here there are 5, gentlemen, HSEMS got 5 levels of the documentation. Remember, there would be a question afterwards. There are 5 levels of HSEMS. First one is vision, mission, values, and HSEMS policy. Then HSEMS framework. Then procedures, system safety rules, working guideline and safety instructions, forms, checklists, records, and report logs and registers. These are the 5 levels of HSEMS in general documentation. Whereas under AIPS, again, same policy is matching. Element, sub-element also matching. There's a framework, there's also framework. Then under processes, working processes like inspection department, operation department, maintenance department, HSE management department, or process safety management department, or asset integrity management department. Then the assets. Asset, for example, pressure vessels, tanks, firefighter like rotary equipment, electrical system, instrumentation system, or there could be firefighting system and so on. Plans mean how you manage them, how you operate them. And then there are the processes which are helping to develop your plans and manage your assets. So it is a more or less same. If you see, this is also triangle, this is also triangle. Leadership in both ways important. Work processes both sides important. Then the management of change in both sides important. Job hazard analysis both sides important. So more or less same. But the aspect point of view, here we have work process management system in HSEMS, work process management system, like hazard analysis, work permit system, cold work permit system, hot work permit system, PPEs and so on, like are coming there, checklists and forms, and various work at height and the safety of the lifting equipment and so, electrical safety, LOTO system, and those comes under HSEMS, where the management of the complete asset system, like operating manual, DCS, ESD system, fire and gas management system, then CMS system, IMS system, all the plant related operations comes under this side of the AIPS. Now, to check like whether some message is being received by the audience. So the first question is, AIPS is a combination of, you have to reply will come. So please type in your basically window. We'll see that. Like AIPS is the combination of AIMS plus PSM, A. B is AIMS plus and HSEMS, T, HSEMS and IMS, or AIMS and AIRMS. So mostly answer is true, and this is answer is basically A. AIMS and PSM's combination is called AIPS. Again, AI is asset integrity management. Nowadays, lot of focus is there on artificial intelligence, so I don't want to be confused with artificial intelligence. Now, one more question, just to check our memory. How many elements are there for PSM, OSHA standard 29 CFR 1910-119? Options are A07, B08, C14, D20. The answer is 2. Yes, I mean, mostly answers are to be being given by the participants. 14. Okay, sir. Now we will go through like one case study where we worked as a company for implementation of a development of and implementation of HSE management system along with the dashboard. So now as we will complete this session, then we will take certain questions as interactive question via MS, like via Zoom. You would be given the platform to ask those questions, and we will try to answer with best of our ability. So see, otherwise conceptually we have reached like what is like AIPS, how it is developed, how it is evolved, and then what the difference in terms of like risk management aspects. So now the system what we implemented, that was for one of the electrical production and distribution company. So this is a case what we developed and we are showing you here as an example. So reviewing and updating of HSEMS management system, updating HSE strategy, coaching project engineer and managers, review and update system safety rules. So this was our scope, and this scope was complied with ISO 9001, 14001, 45001, 50,001, and then HSE Executive UK, OSHA basically USA, HSE 65, then also OSHA, TACA, Department of Energy in UAE, and then procedures and legal requirements were also taken care from the operating company. So here we try to follow the HSEMS in asset lifecycle phases. Up to certain extent, you can say like mechanical integrity aspects were also taken care, but this is how like HSEMS goes. For example, asset development phase you can see, then asset operation phase. Under asset development phase, we have a concept, design, procurement, construction, and commissioning. This is the asset development phase, where we try to apply design integrity up to a certain extent, technical integrity also. When we have asset operation phase, where operation, inspection and maintenance, mothballing and decommissioning. So here operational integrity and technical integrity, there is also overlap. So level-wise, the same 5-level documents were prepared, like vision, mission, values, and HSEMS policy, HSEMS framework, manual, procedures, system, safety rules, work guideline and safety instructions, forms, checklist, records, reports, logs, and registers were also developed. If we take first vision, first level document, vision, mission, values, and HSEMS policy, if you see that, like vision wise, mission wise, or values wise, as agreed or by the operating company, a leading digital utility that deliver reliable and sustainable value to customer through empowering our people. Mission, to plan, develop, maintain, and operate a reliable, secure, safe, and cost-effective distribution system in Abu Dhabi and deliver services that meet or exceed our customer expectations. Same as values in terms of safety, sustainability, collaboration, innovation point of view, and excellence in performance point of view was also part of the level 1 documentation. Here, if we see level 2 framework, so this framework, if you can see here, the name is changed. The same 14 elements based system was followed. So it means the system followed more like OSHA system. rather than following the basically HSEMS UK. Here you can see that integrity and maintenance reliability is also element number 10. Integrity, maintenance, and reliability. So it means that this system is also taking care of the process safety up to a certain extent. Like hazards identification, risk assessment, and management is also there. Engineering controls, safe operations, crisis and emergency management response. So these were the 14 elements. The companies can develop their own elements which suits their requirement as a framework document. Here, same plan, do, check, and act. So here, the element which come under plan is the leadership, commitment, and accountability. Then element number 2, regulatory compliance and industry standards. Then element 5, hazards identification, risk assessment, and management. Then similarly under do, for example, resources, competency training, communication awareness, documentation and information accessibility, engineering controls, safe operations, crisis and emergency management, integrity, maintenance and reliability, management of change, management of third parties. Then under check, incident reporting, investigation and corrective actions, performance review and continual improvement. Then performance review and continual improvement is element number 14. So this way, these elements are basically covered. This is the basically policy, both like English and Arabic. Then when we go to the elements, like if we have to see more details for each element, for example, under leadership, commitment, and accountability, I will not go through all details, otherwise this will take more time. So I have to cover like a 220, almost 150 more slides. So there would be certain rush. Here, since we need to close the presentation by 4 o'clock, Abu Dhabi time. So here's a commitment, policy, visibility, proactive in target setting. These are the sub-elements. The main element and sub-element. Similarly, if you go documentation and information accessibility, HSE documentation and documented information, standards, procedure, and work instructions, control of documented information. There are sub-elements as well. So similarly, let's say performance review and continual improvement. This is called performance monitoring and records, compliance audit, contractor auditing, management review, and continual improvement. Similarly, if we try to see integrity, maintenance, and reliability sub-element, it's a global, like a full system is covering under this. But the safe operation, where the role of operating control room, role of the operators, role of the operating manuals and procedures are also covered under this element. So under this is the first element, leadership, commitment, and accountability, and there are 4 sub-elements. Then if we try to see each sub-element, like a leadership, commitment, and accountability, mean the leadership is leading the organization by standing in the front. And then whatever they say, they implement. Then they are fully committed. They have a very clear policy which should be followed, and the policy is visible through their actions, and all targets are basically properly specified, and KPIs are specified, job responsibilities are specified, functions are specified, and similarly actions are being taken to run the operation in a reasonable way. So commitment means leadership commitment. Policy means whatever we have to do, we reflect that in a documented system, like shall be available as documented information, be communicated across client all function, all basically departments, be available to all stakeholders as appropriate. Then visibility, whatever leadership decision making process, this is properly visible, it is being communicated, and whatever being said as a policy, that is being executed. Then proactive targets, I mean functions are known, job responsibilities are known, KPIs are specified, job targets are specified, and those are being also monitored, right? So this is called like a proactive target setting by the management side. Now, if I go to this, like we explained, now we prepared almost total of 51 procedures. Existing were 26, and new procedure developed were 25. So since we are just giving you idea to have an HSEMS system, first is a vision, mission, policy, and HSM policy document is there. Then framework is there, which I showed you. Now I have a procedure. Total procedures 51, 26 existing, 25 new. So what are those names? For example, procedure for control of documents and records. I'm not reading all, I'm saying one by one, but I will say few. For example, procedure for HSEMS training and competency. Procedure for HSEMS legal and other requirement. Procedure for HSEMS monitoring and mining and reporting. Next, for example, procedure for safe work on roads. Procedure for HSEMS, HSE requirement for contractors and consultants. Procedure for safe lifting. Here, if I go to last slide on the same series, procedure for safety signage and signals. Portable water tool procedure. Procedure for hazardous material. Similarly, system safety rules, just like client system safety rules also prepared. So this is the one of the document as a sample, HSE risk assessment and management procedure. If I try to show you the content, screen is not so visible, but there are contents and all the requirements are specified in the procedure along with the checklist and RACI chart. Now, next level, 4 document is work guidelines and safety instructions. A total of 07 safety new guidelines are prepared and total safety instructions were 15. 7 guidelines and 15 safety instructions. As example, these are 7 a safety guideline. For example, guideline HSEMS vocabulary, HSEQ requirement for consultant guidelines, then HSEQ requirement for contractors guidelines, then contracts HSEQ classification guidelines, health surveillance plan, HSEQ guideline for work in vicinity of the client assets. Then client X, HSE golden rules. These are the 7 guidelines. And then these are the 15 basically were guidelines and safety instructions. I will not read all, earthing electrical distribution equipment, for example, lockout and tagout guidelines, then evacuation work procedure, mobile elevated work platforms, MEWP and ladders. So these are all guidelines as a safety instruction issued and prepared. So health surveillance plan, for example, this is one of the basically guideline procedure. You will see the content. So this is better. You can see that here responsibility definitions, scope, purpose, introduction, then responsibilities, health and safety, health and surveillance program requirement, then implementation and so on. So these are the basically content of that particular procedure. This is another HSE guideline for working in vicinity of the asset. So these are the emergency contacts and appendices for that, which would be used by the technicians and operators and the managers of that particular work center. Now, last but not least, there are forms. 69 forms and checklists were prepared. So these are the list. For example, high voltage isolation of the switchgear checklist, HVLB cable maintenance, for example, then general confined space management, then HSEMS induction checklist, life cycle of HSE risk assessment. There are I'm just not reading all, but these are the various topics which are covered in these forms, environmental objective form, hazard waste transfer form, then qualification questionnaire for the contractors, HSE technical bid evaluation sheet. So standard a hand signal of the controlling the crane operations, lifting plan, pre-lifting safety checklist. So some of these elements are coming also from the process safety aspects. So here checklist for the execution, checklist client execution permit and MOC process replacement in kind, compliance monitoring checklist and so on. So this is one of the sample checklist. The high risk work rescue plan form. So all the like a work detail, the requirements are filled and those are followed by the working team. Similarly, another confined space assessment form. So there's a checklist which is required to be filled by the relevant job officer and the technicians. So question to make you people involved. How many levels are there in HSEMS documentation structure? So question coming to you, so make you awake, otherwise it's a very boring presentation. So how many levels are there in HSEMS documentation structure? So answer is one wrong also. I saw D was given. And mostly answer is right, and that is B, 5. There are 5 levels in the document hierarchy for the HSEMS system. It can also apply on the AIPS as well. So I will go through a sample dashboard of HSEMS, then we will have a question answer session at that stage. Like, what is the purpose? Like a HSEMS dashboard, real-time visibility of HSE performance, number one. Like we can also see what kind of incidents or incidental trends are there. Then what kind of like corrective action we need to take based on those trends. What are the audit like recommendation? How many risk level aspects are there? What are the compliance like tracking aspects? So there could be also environmental monitoring. There could be a incident monitoring. There could be a safety related incidents or even process safety related incident which could be reported as well. If you see here, like for example, a normal dashboard, uh, like we were conducting one audit month back. So the company was using some HSEMS like HIRA, HIRA system, like where they were reporting all the HSE related information in a common dashboard. It was quite effective. Same as Velosi got AIPS software, which also have the similar reporting feature, which could be reported from each site, and then all company sites can be seen in a head office through one dashboard. So here, like total number of man hours, number of days without LTI, lost time incident, incident records, preliminary investigation, final investigations. So all these counts can be shown through the dashboard. Similarly, if you see action and recommendation based on the audit, then HSE incident classification month-wise, like if you see here, for example, fires, unsafe act or conditions, vehicle incidents, LTI incidents, like material tracking things, the first aid cases, or similarly RWC related incident can also be seen. So this is one dashboard. Then next is the HSE audit related, for example, number of audit which was planned and actually done, number of training which were planned and actually done, recommendation as audit closed and open, the drill recommendation as a HSE drill if it is done, how many recommendations are done or pending. So this is like some sample dashboard of HSEMS which can be improved, which can be changed based on the each operation requirement and their wish list. But it is the idea like if we would be tracking these activities at unit level, then we can see the dashboard at corporate level. That's the message. There could be also work permit related issues. There could be environmental related performance and health related performance as well. Like here, audit plan, like whatever the like audit wise pending audits or executed audits. Similarly, internal audit schedule when it to be required to be done, whether it is being complied or not being complied. Then here, a question, for example, which of the following is not a KPI of HSEMS? There is one negative question, not. Like one is a lost time incident, second is near misses, third is fatality, fourth is production. Which one is not HSEMS KPI? Try to fill. Yes, mostly answer is right. It is a production. Like when we talk about HSE, the production is not a KPI for HSE in general. Somebody may also add this as a KPI. It's not a hard and fast, but in general practice, this is the message. Some people may also add production. Without production, there's no safety. So production is also HSE KPI. That could also be a case. But we can compromise on production, but will not compromise generally on the safety.
Assalamu alaikum. Can you hear me?
Yes, sir.
Thank you for your effort and the presentation. I was asking, when we are trying to develop the HSEMS, can we integrate the IAPS within it, or it should be separate?
Basically, if you see the PSM concept, in PSM, mechanical integrity is considered part of the HSEMS. The company we developed, that was a electrical production and distribution company, they also mixed basically mechanical integrity or technical integrity as a part of HSEMS as well. Nowadays, ADNOC is trying to match it as a AIPS, right? So AIPS, it might be a one like a system, but still ADNOC is following two stream, HSEMS and AIPS separately. So this is like a little bit confusing situation. But basically, the OSHA's Process Safety Management System, PSM, covers both HSE as well as technical integrity, practically. Whereas HSEMS in UK, they follow HSEMS and AIM system in independent modes. That would be your company decision.
Okay, well understood. Thank you.
Thank you.
Hello, Assalamu alaikum.
Wa alaikum salam.
Sir, my question is about the model of PSM, as I was there in Fauji Fertilizer in Qasim, where they during their presentation they confirmed that they are using DuPont model of PSM. So my question is whether how many type of models are in PSM and how we can utilize them according to our plant facilities.
Here, like PSM, like a DuPont, CCPS, and OSHA. 3 models are available, right? And if you try to compare those elements and sub-elements, if you try to make a matrix, many of them will coincide with each other, right? So the question is, like, if we try to make it a simplified model, which I'm used to remember, I can share my experience. Like, first thing is leadership and organization, number 1. Second one is basically practice and procedures. Third one is hazard and risk assessment, right, sir? Fourth one is management of change. Fifth one is operational integrity, then technical integrity, then internal audit or performance evaluation. If we try to follow these elements, it covers more or less, then contractors management and so can also come in, but practice procedure can cover that. So this way it can be combined. But as such, like ADNOC now is having 15 elements in AIPS and 21 under HSEMS and 23 under AIMS, right? So these elements does not matter, but important thing is what working processes we wish to cover under these elements. And these elements, in my view, is since I belong to a village, so I can give you one example from a village aspect. Like for me, elements are like a different ingredient placed in the kitchen. Like in the kitchen, you may have to cook food, which could be salty, which could be sweet, which could be any kind of food, but you need to have the basic ingredient like salt, like sugar, like oil, vegetable, blah, blah, blah. So all those elements once available, so you have to make sure whatever food you wish to cook, you have everything available in the kitchen. Same is the case element point of view. Like if you are making any working process, for example, if you wish to manage, let's say, contractor management system. So in contractor management system is one element also, but in the process side, like who would be selecting the contractors? Who would be qualifying the contractor? Under which practice and procedure you will be checking the contractor? Then qualification aspect, their performance and their pre-qualification process, all those aspects, and then how you will measure their performance and so and so. So you have to go back to the elements to check the working process of the contractor. I know that is a complicated little bit understanding point of view, but like hazard and risk assessment is one element also and one process also. Then question would be, who would be the leader? What checklist they would be following? Number then, how the decision-making process would be implemented, how its effectiveness would be measured, how it would be communicated to other parties. So all those elements which are where questions are coming, whether available elements will be able to guide you. So in my perspective, you can follow, let's say, ISO 55001 7 elements, or CCPS 20 elements, or OSHA 14 elements, or HSE Executive UK 9 elements. Whatever you follow, working processes should be developed as per your working site, and those procedures and practices should be implemented, and there should not be any compromise while reporting compliance. So system will work. This is my answer. I'm sorry it is not so easy, but this is what I could explain.
Okay, good afternoon. Confirm you can hear me.
Good afternoon, sir. Yes, we can hear you.
Okay, good afternoon. Okay, so I want to find out from your experience, when is the best time to implement ISO 55001 for a new plant? Is it during the greenfield stage or later as a brownfield facility? And also, what are the practical advantage of each approach? Thank you.
Thank you for your question. See, many like ISO 55001 standard launched like about 15 years ago, and facilities are working from the old time, from like many years, from 50s, 60s, 70s. So the ISO 55001 system can be implemented at any stage of the plant operation. First of all, yes, it's always better to start to implement at the beginning of the plant inception, like when you are starting the plant, when plant is coming into operation. It would be better if the complete documentation is done and systems are implemented. So the answer is the best time is at the start of the plant operations. Otherwise, it can be implemented just like ISO 9001, 14001, 45001. You can implement at any stage of the plant operations. And the objective of the system is like whatever you are doing, you have to record, and whatever you are recording, you have to do. That's the basic thing. And then the role of the leadership, the operational context aspects, the strategic like management of your assets, all those aspects, how you try to manage those all aspects should be documented in a proper form. That is the requirement, and it can be done anytime. Thank you. So now we go start with the next part of the presentation, and then we have one more time for the question answer at the end of the session. Please feel free to share your questions, and we will have this discussion again at the end of the presentation. So this part, like we are showing a case study where we have implemented basically AIPS, AIMS or AIRMS system at the basically EPC stage of the plant. This system was implemented at the EPC stage. With our previous question was there at what time ISO 55001 related system should be implemented. So this was ISO 55001 related system was implemented, and the objective of the system was to make sure the plant would be operating safely and in an efficient way, and it would also be meeting the local regulatory requirement PPGUA system. And this implementation we have done basically in Malaysia. So you can see that HSEMS and AIPS we have implemented to different plant locations, right, sir? Here, what we did, it was like a various studies and the system development, like how the AIPS system or asset entity management system practically implemented. Here, the first system is preparation of the AIM system framework and documentation. Remember the triangle, the 5-level triangle. So also those 5-level triangle documents are produced here. Number 1, framework and associated documentation. Then plant operating manual and procedures. Then inspection standard operating procedure. Then maintenance standard operating procedures. Then to develop the CMS IMS system, so we carried various studies like development of asset register, then RBI, RCM, SIL, and then as a part of the same system, we carried out RBI study for the topside equipment, piping system and pressure relief system. Then RBA study for the crude oil pipeline, gas pipeline, for subsea jacket structures, for topside structures. Then preparation of S register, FMECA, RCM analysis, including PMRs and job plan development. Then preparation of the bill of material for the various equipment, development of job plans or the task list or MWIs. Here, then identification of dead leg, small bore identification, then injection point, crane monitoring and support locations, and the preparation of their register. Preparation of inspection drawing for topside structures, preparation of the inspection drawing for the subsea jacket, then preparation of the inspection drawing for topside piping and equipment, preparation of inspection drawing for pipeline and riser, seal review and assessment, spare part optimization, except pipeline, then spare part optimization for the pipeline. Then implementation of SCs, identification and management system, and implementation of HSEMS and CMS system as a part of the overall project. So this basically, if you see, these all processes we implemented. So it was done at the project, initial stage when project was being built. So these all studies were being done in parallel. So when we go to AIMS system, so in AIMS system, it was comprising of 17 documented systems. We can see here, like if I can show you here, AIMS. Then we have a design and project management. PIMS is a pipeline integrity management system, SC management system, pressurized equipment management system, then pipeline integrity management system, structural integrity management system, civil integrity management system, electrical equipment integrity management system, instrumentation and control management system, then rotary equipment management system, quality management system, then is the ERPS, then PSMS integrity management system, lifting equipment integrity management system, IMS means inspection management system, and MMS is a maintenance management system. So these all basically systems as a documentation wise, those were prepared like 17 document. Now, if you see the one document I'm showing you as a sample. So it's an asset management system which comprising of, for example, complete life cycle process for AIMS, design, procurement, build, commissioning, operations, change, improve, abandon. Then asset management systems, including all those 17 systems, are referred here again. And then at the end, if you see that, like asset management system interface and ownership, execution point of view, development phase, operation phase, aim, result management, then system administration, audit, physical and system audits, accountability and responsibility, key performance indicators, interfaces, RACI chart, and so on. Now, next part was the operating manuals for the pipelines, and otherwise other topside assets were also prepared. And this was the content of the basically pipeline operating manuals, one of the manual like. So you can see that like it is a real documentation. Introduction, company PIMS policy and objectives, company organizational structure, PIMS organization chart, and like legal and code compliance, pipeline integrity management program, and so on. So this was complete documentation for the one pipeline integrity management system. Similarly, for other processes, these manuals and operating procedures were also prepared. Here, just showing you the example, like I gave you the title of the documentation in the previous HSEMS. Similarly, here there is a 74 inspection standard operating procedures were prepared. I will not go through the complete list, but like acceptance of the mouthball certificate for plant equipment. If I see next, inspection procedure for WHRU, magnetic flux leakage tube procedure, then management of inspection, calibration and certification, material identification. Similarly, if you see monthly repair and recommendation report preparation, monthly SAP work generation, quality assurance of equipment fabrication, review and revision of inspection reports. So this way, 74 basically SOPs were prepared as per the company needs. And this is one of the example like pipeline integrity management program prepared, and this is the documentation, client name is changed. So here, like the complete procedural requirement are documented in this document. So second set, like we prepared 63 basically maintenance standard operating procedures SOPs, and those who are also similar to like maintenance procedure for gas metering package. I'm not reading all, a few example as a random. Then maintenance procedure for crude export, condensate export, crude booster and condensate booster pumps, ppm. Similarly, structural repair and maintenance procedure for top site. Then piping maintenance procedure, tool management system procedure. So all the procedure what company may require, those are prepared for operators and technicians to be using it. So this is the example, maintenance procedure for aeration tank feed pumps. So this procedure covering the role and responsibilities, safety precautions, hazard and control measure, detailed procedural steps, and the record and documentation, references, and receipt chart also. So now we completed the procedures and documentation. Now the various studies like RBI, RCM, and SIL, what we did to implement CMS and IMS system, which are not compulsory to be done. You can develop CMS system, IMS system without conducting these studies, but these studies help you to optimize your resources basically. Here, for example, it is the risk-based inspection program and data for uploading into Vail-Plant software for static equipment, piping system, and pressure relief devices. So these are the basically Croinian loops, basically perform RBI assessment, including preparation of asset register, Croinian loops, risk ranking, detailed RBI report, and C&I manual. C&I means Croinian and inspection manual. So asset covered. So we covered all static equipment, pressure vessels, heat exchangers, approximately 300 tags, piping system, approximately 4,000 tags were covered. So here you can see the outcome of the software, like we have allocate damage mechanisms, assess probability of failure, assessment of consequence of failure, assessment of risk, assessment of inspection effectiveness, inspection plan. Then dashboard reporting like remnant life, the risk, the inspection and PMs, and then standard reports which are part of the software, and the asset passport as well for each particular equipment and piping tag. So this is the equipment and piping side, like the static equipment side, inspection history recording, ultrasonic thickness baseline survey record were brought into, inspection history, visual inspection records are brought into. Inspection drawings are also prepared based on the TML, CML marking. The preparation of inspection drawing for topside equipment and piping system, all static equipment covered, 300 static equipment and 4,000 piping systems are covered also. Then we also covered dead legs, going under insulation points, injection point, and small bores, and all those equipments are marked on their drawings and their register prepared. So here you can see the small bore and injection point, very small bore points are marked on the drawing, and dead legs are marked here on the drawing. Then risk-based inspection study report along with the software that is also developed so that people can use as a record or reference in future. Then pressure safety valves, basically we covered under like a FMEC approach, and the total PSVs studied under this scope were 200. So we covered FMECA approach and then developed the inspection and basically bench testing program for these PSVs. So here you can see these are failure modes, allocate failure modes and their assessment. Then there is a probability of failure and consequence of failure and the risk assessment and the risk matrix. And then this is the inspection plan for the PSVs developed. Here, this is the dashboard for the PSVMS, like the same risk side, reliability side, like based on the MTBF of the past history. And then this is a reporting feature, and this is the Vail-Plant, basically the assessment report of each PSV. So my speed is a little fast because I have to cover this presentation before 4. So this is a target. So that's why you have to bear with me. So for pipeline RBI study, we basically divide the pipeline into various sections and segment in the pipeline. You can see where all the internal and external damages are marked, and there each section is assessed, and the dashboard also you can see for the other assets also. Then section of each pipeline, we assign damage mechanism, each section of the pipeline probability of failure, consequence of failure, then condition summary of each section of the pipeline for each damage, then risk assessment profile across the basically route of the pipeline, and inspection plan. And then dashboard on the same pipeline side. This is the basically pipeline assessment, and this is the basically standard report on the whatever report we want to draw from the software Vail-Plant, that can also be brought into. Then this is the basically oil and gas, this offshore pipeline for the oil side. Here the same sections, survey records, crossings, inspection data, and which can be used for the analysis. So here defect screening, code check as may be 31G, and then there are risk assessment, then clockwise orientation of all the defects, and assessment of the results under the code. This is also available in the feature and done. Now inspection and pipeline risers inspection drawing we also prepared. Like you can see, there is a complete route of the pipeline. You can see that it is a small drawing, but it is a big one on the A1 or A0 size. Then for the RBA study for the jacket of the structure, where all the marking of the tags and joints of the jacket was done. Then identification of those members applicable, basically their scenarios like POF, COF, TIG life, unity check, all data is updated in the system. Here, this is the POF assignment based on the fatigue, accident, anomaly, corrosion, confidence, and design utilization. So fatigue analysis, this data is provided, then COF assessment is done, risk assessment is done, then the next inspection plan is prepared. And the same is converted into the basically as a passport of that particular structure, where you can see that how many components of this structure are high risk or low risk, and accordingly you can see the dashboard and reporting feature. Then inspection drawing for the structure also prepared, like what kind of inspection and where we need to do detailed inspection plan marked on the drawing basically. Then FMECA analysis for the electrical instrument rotary equipment, where asset register is prepared, then FMECA is done for each particular tag, and then probability analysis, consequence analysis, and then risk ranking, and then we prepared the PM plans for all the tags. Like here, allocate failure mode, FMECA analysis, probability assessment, consequence assessment, risk assessment, and PMR, and then job plans are prepared. So FMECA based RCM analysis, here if you can see the dashboard, in reliability side, risk side, inspection PM activity side, maintenance side, the CM work orders or bad actors identification, failure replacement, this is the reporting feature, and this is the equipment wise, basically passport assessment report, asset passport. Then below material, basically prepared based on the basically PMRs, like for each PM activity, the craft, their man hours, and the required BMs are also identified. Then these are job plan, or we call it sometimes MWIs. For each basically PM activity, these job plans are prepared. The total of basically total object types were 450, and job plans prepared 2000. Then SIL study basically we did prepare the asset register for all the SIF loops, and their SIL classification and SIL verification was done, testing interval was prepared, and general report is also prepared. Here you can see SIL classification done by first by risk graph, and then it's also done by basically LOPA, and then accordingly testing interval was calculated. So now we are going to the implementation of SC identification and implementation of SC management system, that is also done, and identification was done based on hazard workshop, BOTI was conducted, and then all HTCS was identified, and their performance standard were prepared, written scheme of examination was prepared, and then SC system was implemented into the CMS system. If you see here, like here, prevention, detection, and basically all those aspects, these are prevention related various performance standards. The categories are shown, and accordingly, basically these were assigned various inspection and PM activities as per applicable performance standard. So then implementation of APM, CPM, CMMS and IMS system. Basically, we showed that already. So like it was a Vail-Plant which was used for the all management of all these operations. So here, like what we implemented, APM, as we implemented, CMMS we implemented, and IMS we also implemented. Here, like this is the basically complete screenshot what we implemented: CMMS, ISMS, APMS, PEMS, PIMS, onshore, offshore, EIRMS, PSVMS, SIMS, lifting equipment management system, well integrity management system. So it's a modular based software. This was implemented for this particular client. So these are the various modules, like in each module what we cover: asset performance management system, pressure equipment, the same, like their descriptive form of the same modules. So what is the modular approach? It can recognize voice, hierarchy recording, then dashboard overview is available, asset management aspects are there, condition monitoring is there, root cause analysis feature is available, failure replacement and maintenance anomalies are recorded, KPI management system is there, integrity operating windows can be managed, risk assessment part is available, estimated going rate can be done, FMEC analysis feature available, inspection plan and scheduling available, inspection and maintenance history can be recorded, UT data loggers can be used, integration interface with other ERP systems, other system also available, customized and standard features are available, mobile application also available. So this asset performance model, like the same KPIs, which are we have seen in all the modules in the previous slides, we can combine into one system, which is already available. So you can see RLA, metal loss, growing rate, anomalies, risk distribution results, MTBF, MTTR, bad actors, PI historian data can be correlated, sensor or IoT data can be correlated, condition monitoring data, work order status KPIs are also available. So here the CMS system where the various work orders and like a dashboard on the work order system is also how the work orders are being executed, how the data is being recorded, how the performance is being evaluated. Then like this is the PMS system I showed you earlier is implemented. This is a SIM system which I showed you earlier is implemented. Then PIM system also I've shown earlier is implemented. Then electrical instrumentation rotary management system is implemented. Then pressurized safety management system is also implemented as part of APMS. Then lifting equipment integrity management system is implemented. Civil integrity management system is implemented. And CP management system, cathodic protection meters management system is also implemented. A well integrity management system is implemented. And ISMS is the inspection schedule management system is implemented. And last but not least, the APMS. So this is the integrity KPIs which are calculated based on the performance. This feature can also be used by the operator. Here, question, so as you are not sleeping, the question is which software was used for management of AIPS in above case study? Just, I'm not trying to promote our Vail-Plant, but I want you to remember it was used. So answer, yes, coming, mostly right, is the B. Velosi Vail-Plant is used for this AIPS implementation is this Malaysian client. Now, one more question. AIPS include following management system. AIPS include following management system. One answer is true. Technical integrity management system, operational integrity management system, design integrity management system, HSE management system. So the answer is E. AIPS basically include all of the above. So now last part, but to make the study, like we have done HSEMS and we have done AIPS, but there is operational integrity. One is the operational integrity, not HSEMS, not incidents, not lost time incidents, not near misses, not environmental emissions, or not a impact on the health, which is covered under HSEMS. AIPS also, what we did up to now, we did not go to control room. What is being done by the operators? So one of the AIPS activity is the operational integrity. The operational integrity, the key parameter. This is one serious message over AIPS system. AIPS mean again asset integrity and process safety management system. Here alarms like plant is being run by the operators, right? I know that I'm going to the last part of my presentation, and maybe question answer may go a little more than the 4 o'clock. But here this is very important to know what is the role of the operators. If they're able to attend all the operators, all the alarms, whether they know that if one alarm is ringing, what is the corrective action? What is the process safety time to react for that corrective action? And then what are the critical alarms? Which are the medium critical alarms? Which are low critical alarms? What are the diagnostic alarms? Which are the stalled alarms? So alarm management system is also part and parcel of process safety management system or AIPS system. Next thing would be also ESD management system. Mean in case of any emergency, what shutdown features would be available for operator to take action. I would be a little fast, but this is also one of the key activity. Since I am covering AIPS, so AIPS, if I say four systems, sir. One system HSEMS, second system AIPS, so-called you can say AIMS. Third system alarm management, control room control. Then ESD is also part of the control room. So if you match all four systems, then we can say our system is intact, and that's called AIPS concept. So alarm management, see, it got alarm management philosophy. It got like almost 9 steps, what we call like alarm identification, alarm rationalization, then detailed analysis and implementation. Implementation means the buying the DCS system, then operation, then its performance management, and then audit and control. So here, one particular client, we did this study, and there were 17,000 alarms were involved. And just quickly, I'm going through. Then direct alarm tags, event, like here, if we have to check the alarm, one is the alarm control room can also report daily activities. And one way is if you take out all the data of the alarms in a PI historian, then our Vail-Plant AIPS, VAIL-AIPS, basically not Vail-Plant, VAIL-AIPS can demonstrate what are the alarm basically behavior, what kind of alarms are coming the most. So here, like alarm philosophy point of view, the alarms are being managed by DCS, then data coming to PI historian, then we take the data from PI historian, then try to find which are the most repeated alarms, which are the most like diagnostic related alarms, and how many alarms are coming from the critical side. Otherwise, alarm wise, you may not have a record in the DCS. This is the problem of the DCS. So now, like if we take the alarm data and we bring to the PI historian and then bring to next AIPS, then we can demonstrate those KPIs and alarm matrices as to match if the progress or the monitoring of the alarm is being done as per the company policies. For example, here we had 17,000 alarms, and but these alarms are in thousands. But this is a small facility. That's why a sample case study is shown. 17,000 alarms, which coming ESP and Korean inspection system are currently disabled. But there are 11,000 alarms which are disabled practically. Alarms are not available on the PNIDs and serve only as a pre-alert. There are 4,000. Actual process alarms on the PNIDs are currently 1,982, but total are 17,000. Then well group, CGF group, multi-phase pump group, export pipeline group, and then this one are given 308 types. Further gone as 308 type of the alarms. Then how these alarms are distributed, like on the various sections, like a biocide injection package, closed drain and vent system. I'm not reading all, but if say type 1 oil producer well, type 1 oil producer well without ESP, type 1 water injection well, and so on. So totally 17,136 alarms. Here, identification like in the AIPS, what kind of data we can have, like alarm equipment, it's a variable, set point, the severity, consequences, and so on. So then rationalization point of view, the high alarms were 19.22%, medium alarms are 15%, 15.19%, low alarm 1,365%, total 1982 alarms where rationalization is done. Now, if we say alarm monitoring history for each alarm, we can monitor when it particularly rang and when it was repeated, the data can also be seen. Here, alarm KPI view, if you see that general KPIs are like there should be, let's say, less than 10 alarms per hour, right? Then if you see here, alarm per hour per operator console, then alarms per 10 minutes per console, then percentage of 10 minutes period containing more than 10 alarms, maximum number of alarms in 10 minutes period, percentage of time the alarm system is in the flooded condition, right? Actual versus like the target. Then quantity of chattering and fleeting alarms, standing alarms. Then there could be also shelved alarms. So all these alarms are covered as per the target and actual value, and that can be presented to the management. And it is one of the key process safety parameter, because the operator are the first line of defense for the plant operation and plant safety. So here you can see alarms point of view. Here the same alarm KPIs like a 10 minutes flooded, standing and chattering alarms as per ISA 18.2 client Y. And here you can see the alarms which are running here. For example, here diagnostic alarm, P1 alarm, P2 alarm, and P3 alarm. On date wise, how many alarms were being seen, right? This is the first one is the total alarms. Then there is the standing alarms. Then this is the shelved alarm, and then there is a suppressed alarms. So all the alarms in number of quantity wise can be seen via this graph if data is available. So those are the type of the alarms. Now, since time is lesser, so I have to rush through. Last part of the presentation is basically SIS and SIF. SIS and SIF, like here, like all the ESD shutdown systems, like they are covered. First of all, hazard studies done with the TMEL, like a targeted mitigate event likelihood is defined. Then accordingly, LOPA analysis or risk graph analysis is done, and then accordingly, life cycle management aspects of the SIFs are managed. I'm rushing through. Sorry for it. Here we know that there are various layer of protections are there, and our main role here, how the process, basic control system, alarm and operator intervention, safety instrumented system, which is the SIF, then physical protection or barrier PSVs, physical containment like bunds, fire and gas detection system, plant emergency response, and community emergency response. These all are the layer of protections. And over we covered earlier the alarms and operator intervention, basic control system and process. This is the inherent safe design, compliance with international standards. This is the operator role. This is the ESD system role. This is also mechanical safety, bunds in case a leak happen from the tanks, then fire and gas detection system, then emergency response plan, and where like a basic control system would have fire and gas detection system as well. Here. Now, what is SIL? SIL is basically stand for safety integrity level, which define the reliability level of particular ESD system. That ESD system consists of sensor, logic solver, and final element. Like here, if I see, first we need to measure, which is a transmitter. Then we need to think, which is a logic solver. Then we need to have final action to close the either motor, engine, or we have to close the ESD valve, or we have to open the blowdown valve. This is called final element. Here, for example, SIL 1 is a lowest SIL, which means that 1 out of 10 failure rate acceptable. SIL 2 mean 1 out of 100 failure rate acceptable. 3 mean 1 out of 1,000 failure rate acceptable. And SIL level 4 mean 1 out of 10,000 failure rate acceptable. It means that 90 to 99% reliability, 99 to 99.90, 99.9%, and greater than 99.99%. SIL 4 generally impossible to achieve. The maximum SIL level remains between SIL 1 and SIL 3. Here, this is the one methodology. There are three methodologies for the SIL determination technique: qualitative, semi-qualitative, and semi-quantitative. So risk graph is a semi-quantitative, and then we have a LOPA, which is a semi-quantitative technique. I will not going through that steps now. And this is basically a LOPA analysis worksheet. And then this is the testing interval for the each loop, and then spurious tip calculation rate also, which is acceptable rate are there. There's a sheet available. So we will be presenting this presentation on the YouTube also, and with the slow motion you may see that, but I'm not explaining because of the time constraint today. For SIL, we have a separate webinar also available on the YouTube. You can see that. Then SIF operational history. Basically, this is the way I wanted to show. Like a Vail SIL software along with the AIPS can show like how many SIFs basically activated automatically, trip over time, whether those were intentional through spurious trip or by the operational intervention. Then how many initiators got initiated, like a SIF operational history for initiator side, then logic solver side, then final element side. So each record is being maintained separately. Then the trip types, for example, if those were manual trips, then automated trips, spurious trips, or no trip on demand also is one of the failure case. Like when there's a ESD, you want to have a trip if a system is not working. Then Vail-SIL software also, this is the screenshot of that software. Here the functional safety testing dashboard. Then I'm going to the question to keep you a little bit involved. Which of the following not an alarm management KPI? Alarm management KPI. We have to differentiate between alarm management KPI and SIF management KPI. Options are number of alarms per hour per operator, looks like a SIF KPI, number of chattering and fleeting alarms, percentage of time system was in flooded condition, no number of SIFs activated per day. The answer mostly coming right, but there's one A also, number of alarms per hour per operator. No, this is the alarm management KPI. Only SIF related information is not alarm management KPI. The answer is D, mostly true. So now we are just showing AIPS dashboard, and then we will go to the question answer so as we can conclude the discussion. The AIPS dashboard, just trying to show you, because we started with what is AIMS, what is HSEMS, what is basically PSM, then what is AIPS, then HSEMS case study, then AIPS case study, then alarm management, then we went to SIF management, and now if we have a complete centralized dashboard, how it look like. There would be certain repetition, but I am concluding my discussion. So AIPS dashboard provide a centralized visual overview of asset integrity and process safety matrices. Track KPIs for equipment health and safety barriers. Enable data-driven decision to reduce risk and prevent incident. Okay, sir. So here KPI monitoring, track leading, proactive, and lagging KPIs. Where the leading KPIs are barrier health, for example, inspection completion, maintenance backlog, safety system tests. Lagging KPIs are process safety events, for example, loss of containment, near misses. Risk visualization can be there, compliance tagging could be there, action and workflow management could be there, data analytics and reporting could be there. So now general KPIs are asset integrity management, alarm management, SIF and CIS management, audit management, risk register, MOC management, HSE management, operation event log management, work management system, work permit system management. So here I'm just going through AIPS overall dashboard. This is coming from the total number of man hours and number of days which I showed you earlier also. Then asset integrity dashboard, like the anomalies, for example, here SIS activated on actual anomaly, by operator on actual anomaly, SIS attentive, SIS auto activated, and others, right? And similarly, alarms which are not attended or so. Here, alarm management which showed you earlier, alarm management KPIs. Then the alarm management dashboard is the repetition coming in. Then there is a Vail SIL, also the history of the SIL, like SIFs, how it recorded. Then the master internal audit plan, this also could be one of the activity, audit management, schedule management. Then overall risk register dashboard, coming residual overall risk or the inherent overall risk, both. And there is a list also behind attached. It could be tracked. Then management of change dashboard. Then HSE dashboard, which we like a number of incidents we showed you earlier also. Then, yes, it covered earlier also, action recommendation. Then process safety dashboard. So we concluded the discussion, and now we're going to last question, and we'll take the other questions also. which of the following is not a part of AIPS KPIs? AIPS KPIs. Here, AIPS is basically not bringing in overview, but if HSEMS is also brought into AIPS, then it could also be. Like lagging KPIs is a part of AIPS KPI. Number 2, safety critical equipment compliance KPI. It is AIPS. Then leading KPIs, for example, schedule compliance and procedure adherence. And the pitfall or near misses. Generally, these are HSEMS KPIs. So these are a little difficult, but we are not saying this is the set policy, but this debate is ongoing in the industry. Every company may have different policy. So here, pitfall or near misses are not the basically as a part of AIPS in general terms, but it could also be. So this is a qualification.
I would like to know whether the solutions which are there as part of Velosi, I would say, and basket, can they be applied on maximum without any version limitation? And are they on-prem or on the cloud only?
See, or like a system can be used, is available. You can have place the system on your server, and you can also basically place at the cloud as well. So both options are available. It is a web-based system. It could be on premises. It could be on the Azure or other clouds. And system can work like whatever stage you are. It can be collaborated or it can be configured based on your needs.
Yeah, I mean, if we migrate to MAS 9, it will be competitive.
Yes. If you're using any system, then you don't need to use AIPS. So the message is, if you're using any system, and even Excel spreadsheet, if you're using any dashboard, which is a live relationship with the document entry level or information entry level, it should work. So we are not educating that you should go with AIPS 100%, but like you can have any similar system if you are using, you're happy, and that is the objective basically. So I don't want to use this platform as a sales platform. Okay, sir.
Power BI as integrated with Maximo for
yes, Maximo or SAP, it can be integrated. Yes, Maximo, SAP, or it could be IMS system also. It can be integrated. Then alarm management system is also, which is coming from the DCS, right? And also the ESD system, which is also part of the control room. So it can be our FNG system also. So there could be multiple integrations there.
Yeah, we have Honeywell DCS system along with the Maximo 7.6 right now, but we are trying to upgrade to MAS 9. And the historian also, we are in the process of upgrading.
You're on the right track. If you continue, it will help. Yes. Thank you, sir.
Hello, Assalamualaikum, sir.
Walaikum salam.
Sir, my question is this: what is the cathodic protection in oil and gas related, like tanks and pipeline? How can we management system use this method?
See, like you know that cathodic protection is the corrosion protection system for the underground or underwater assets, right?
Yes.
So
Right,
if you have any underground asset or underwater asset, then you can have either a sacrificial anode system or you can have a ICCP, impressed current cathodic protection system. And when you have applied those systems, then you have to see whether your CP system is able to protect these assets and their negative potential is above minus 850 millivolt and less than 1200 or so. So in that monitoring aspects, then performance of the rectifier like anodes, the transfer rectifier. So those aspects, you have to monitor the performance of the asset as well as the protection level on the CP test post can be monitored by the system. Okay, sir.
One more question.
Sure.
Is cathodic protection can protect painting system like paints?
See, cathodic protection system, which is applied on the either underground or on the underwater, the base like a mechanism is these structures are coated by painting system, whether epoxy or 3-layer polyethylene, and that is the first layer of protection. And then if there would be any damage or any painted or the coating condition, and if there would be interface of the oxidizing agent, then CP system would basically compensate the electron loss. So CP system is always designed with combination of the coating as well as the CP system. So it's not
Thank you, sir.
alone. Okay, sir. Thank you.
Okay, sir. Thank you so much.
Ladies, basically it's 4 o'clock. Time is already 5 minutes late. So we'll take a break now. And thank you very much for your interest. And we will be coming back with a new webinar next month. So till then, thank you very much. Have a safe where you are. And we look forward to your feedback either on our webpage or wherever you get the opportunity, so as the message can go to other audiences as well. And the same presentation would be also kept on YouTube, and you can download this presentation from the YouTube also. Your feedback is always very, very valuable, and it encourages us to do better homework for the next webinar. Thank you very much, and have a nice day.